All solid that results when the region enclosed by the given curves is revolved about the x-axis. Y is equal to sine x, y is equal to cosine x. I am going to graph y and the that I want to worry about is what happens when I take the sine of pi over 8, and I am going to use my purple pen to graph the sine wave from 0 to pi over 4. Is this, you know what that is? And for I put in rate and that 0.3 going to go and I can plot the value here. I'm going to put an approximation symbol of 0.4. Do over to plot the decimal. And then I'll connect my dots. Label the point pi over 8 because the y coordinate, I don't want to list the y coordinate as a 0.4. I want to be able to the cosine of 0 is 1. The cosine of pi over 8, we'll figure that out in just a moment. The cosine of pi over 4 is the square root of 2 over 2, which is about a point. Cosine of 8, I'll put in the calculator, is about a 0.9. So I'm just saying this is y cosine of x. And I have all the necessary points. Again, wanting to exact value, I only have the decimal for that because pi over 8 is not an angle on the unit circle, so I wouldn't ask you to lay that point. Y value, exact value. So if you do label that point for x equals pi over 8 for both sine and cosine, you need to give the exact x is pi over 8 and the y value is sine of pi over 8. That's kind of safe to label it that way. Cosine of pi over 8. So don't lose the approximated 0.4 here and the approximated 0.9. That's why I would not ask you to label that point. Now, since it is you can see that the washer, the center of the washer always starts at the x. X minus we're integrating with respect to x. The axis of revolution is the x-axis, and the cross sections are perpendicular. Again, use an extra set of grouping symbols here. This f of x represents the larger radius, and this one, g of x, represents the smaller. The curve on the top, that will represent that distance from x-axis to curve on the top. Cosine x is going to be the larger radius. So I G is the smaller radius of the washer at any washer I want to take, even here. When I go up to meet the curve from the center of the washer, the rest of this is taking out, I'm going to take out the pi almost forgot to do that. I'm going to use the squared x minus sine squared x is equal to cosine of 2x. So I'll do that next. X du is 2dx. If x is 0, then u is 2 times 0, or 0. If x is pi over 4, 2 times pi need a on the inside and a 1/2 on the outside. In this step, I'm just going to change my colors, and I'm going to put a 2 here and a because we've integrated the antiderivative cosine is sine. So then the fundamental theorem of calculus where you go for that is here, the double angle identities. We're using the fact that by our integral to cosine, in this case not 2 theta but 2x. Now, in terms of the next problem, to together, I think that I like how I incremented my axes better than how I incremented my axes here. I made it a little bit smaller of a graph by letting every area of the cross section. So if our cross sections are discs, f of x squared. If the cross section is a washer, then when it's a washer, washer. So A of x is replaced by the washer formula as opposed to just the disk formula. The cross section is a square. So I reviewed on the side that the area of a square is side squared, where S equals the side. No, when it's a disk or washer, and we're integrating with respect to x, or the axis of revolution is the x-axis. But what does axis, if the axis of revolution is the y-axis, it's going to go from C to D. But I need to show you what happens in terms of x. So that's why the paper that I did increments 1.4 on the x-axis, and I wanted to graph from what they said. Then you multiply, that's 5 decimal, 5 a 5 to the nearest of 3.5. So that's how I was able to plot that point. And then we'll give the exact value. Pi over 0, 0 times 5 is 0. So I've got 3 good points. If you notice, these cross sections are perpendicular to the axis of revolution. Each cross section So here's the setup. I have the volume is equal to the definite integral from a to b, a of x dx. So this is the area of cross section that and I side squared already set in there. And you represent side squared, and made a little indication to turn over. The identity called a half angle identity, and that's also on your formula sheet, formula packet. That cosine variety is 1 of 1, 0 to pi over 2, 25 halves cosine. The first one will not involve u substitution, but the cosine of 2x is not involved. I just derivative 2, so we're still in x the whole time. And the fundamental theorem of calculus is pi over 2 minus 0. We have to take on this second definite integral. At this step is where sine. The fundamental theorem of calculus is going to say sine of pi minus sine of 0. Well, the sine of pi is 0. Of 1 0 pi over 2 plays out to be, when you do the math, 5 pi. The with u sub actually led to a final answer of 0. And the work we did here, where we did not have to do u sub, led to the problem. I want to show you your Blackboard homework, and I don't want to write on this. This is like the volume of the solid using cross sections, which are squares. Find the volume of the solid that results when the region enclosed by the given curves is revolved about the x-axis across. As multiple answer, it will tell you if you do this next and follow the directions, and y equals 1 over x, and x is equal to 1, and x is equal to 4. So basically x equals 1 to 4. And the x-axis is important of revolution, and the cross section so we need a really good graph of what's going on here with this particular problem. I am going to not use graph paper, graph on my paper. On my x-axis, I'm going to go, and I'm going to put 1, In purple, I'm going to graph the square root of x. You can make an XY chart. Graph first and then go back in and make solid what we need. And I'll make that dotted. And I'm going to label the 4, 2. And I can see from x equals 1, x equals 4, that point of 0, 0 does help me graph the square x. And that is y equals the square root of x. And then I'm going to work on y equals 1 over x. And I get a half. I'm going to put in 4 and I get 1/4. So I'll plot that in color. And so does the only part I want solid is from x equals 1 to x equals 4. From 1 to x equals 4. X equals 4, x equals 1. Those are my vertical lines. Those are bounds. This is going to be 2.5. Y equals 1 over x, so x is 2, y is a half, x is 4, y is 1/4, and then we already have the 0.11. And I'm going to draw in my cross sections. I need to do this. Go back in between. Cross sections are squares. I want to show you quickly that I have the square root of x. At the same time, the calculator does a much better job than I did. And I really only want to look at the first quadrant. So is 1. It's very the one on the here, purple here, is the square root of x. The one on the bottom to the x-axis, the axis of revolution, and those cross sections are squares. So you can use your graphing calculator, but attention to your region. Now we set it up. The general formula is a to b, a of x, quantity squared, or and I'll put volume. A of x represents the area of the cross section. The cross section squared cross-sectional square as we go from x equals 1 to x equals 4. Top minus bottom. Top is the square root of x in purple minus the one on bottom in blue is 1 over x. So the is simple. Well, actually, a lot of students just square the first term and the last term, but you have to FOIL this square x. So the square x times, and I'll do this out to the side, FOIL. Square root of x times square root of x. X over x. Negative 1 over x times square root of x is another negative square root of x over x. And then a negative 1 over x times negative 1 over x is plus 1 and over 1 over. In order to find the antiderivative, we're going to have to use the power rule for all of these. So the next step is x over x to the first plus x to the negative 2. We want x to the 1 half x to the negative 1 half power plus x to the negative 2 power. Now this is the point where you can start utilizing your power. Exponent and then divide by negative 1 half plus 1. Negative 1 half plus 1 is going to be a positive 1 half. So this negative 2x to the negative 1 half power, it becomes minus 4x to the 1 half power. From 1 to 4. I have a lot of students that actually write. I don't really wish for you to do this to be students that say 1 plus 1 divided by 1 plus 1, and that's how you get the 1 half x squared, plus 1 divided by negative 1 half plus 1, and that's how you get because it's 2 divided by a positive 1 half, which is a negative 4. But trust me, that simplifies to negative 4x. Or you not do that because you're trying to show me the antiderivative here. Technically, even though things are not simplified, this is the antiderivative. Before you go I'll show you in one. In order to show the fundamental theorem of calculus, I am going to square minus 4 square roots of x minus 1 over x. The substitution process might be easy. All of that simplified to a that's going to be 1/2 of 16 minus 4. This is off to the side. 5 over 1 equals what over 2? 1 goes into 2 times 5, 10. By 4. So if you've not tried that one, that was Blackboard homework number okay. So with that being said, that concludes the video that I wanted to show you a huge portion of that lecture, but I wanted to show you a few more examples of volume by disc, washers, and also squares at the same time. Your algebra, very important skills. The next video will be volume by